share. So, can we start? So, welcome at Transform 2022. I'm really hoping that next year we'll do it this event live, and that will be far better impact altogether. So, a few words about myself. I'm Catalin Gheorghiu. I'm solution architect at the EPAM system from the year 2011. Each year, Microsoft awarded me the title the most valuable professional. Now I'm on 3 categories. I'm on Azure, Windows development, and IoT. I'm also a Microsoft certified trainer and Intel software innovator. So we're going to talk about Azure Percept. And as you see, Azure Percept DK is dead. Long live Azure Percept. We'll have a lot of slides. Let's start it. Let's get started. First, what we're going to see. I want to see what's all about Azure Percept. Then we go about Edge, about computer vision, about practical uses of it. And then we'll see what is the future, because the DK, what the art is DK, is dead. So let's move to the slides. This is Azure Percept. Now the presentation is over. No? So now we're going to change what we are sharing. And in fact, I will get back to this picture a bit later, but I will change what I'm sharing. I'll share everything and anything because I want to share. So I want to share everything. So now we will move to. Okay, and this I need to close. Sorry. Something crashed. The Chrome open, but this will. I should have taken the time to open the tabs, and nonetheless. Not this one. Okay, this. Give me a second. Now I'll give you this slide. In the meantime, because strange enough, be able to get the slides, the site I want. So what we're gonna this is why on this kind of presentation, even on the simpler thing. You will really enjoy help of somebody, because until you troubleshoot, Percept to have open, that will do. And until you get things started, very hard. Pause. So, and now we can really get started. Let me share yet again everything. So let's talk about first Why in the earth we're talking about computer vision and everything? Here we got on the, let's say, on the very practical part. We have got close to the computer vision because it was a practical use of it. Have done a lot of projects in the area, and the results were pretty remarkable for the effort set. But how we do it easily? And what are the terms? This is an external site which has the best, let's say, view, best explanation of what's what. What are the terms of classification, localization, detection, segmentation? Classification, as you see, and I'll try to make this picture big. Not that big, but I'll say this website, they have their own product in the custom vision. Yeah, it's not touched in this presentation. We are talking about these pictures. So classification means to know that it's somebody called Ellen in this picture. Localization is to know where it is. So essentially you get bounding box. Detection, you get them all these where they are, and segmentation to know exactly where they are. Okay, we're talking about the good one, Percept DK. We have it one running here, and as you most probably see from the background noise, yeah, we'll have something on them. So what's the Azure Percept DK? There is an edge device which has a camera and a microphone. Okay, getting back, what's an edge device as Microsoft sees? So if you ask Microsoft about real time, about what are the problem and issues with getting real time, they always will tell you that the biggest problem it's the time to send data to the cloud. So okay, their idea was, okay, why to run everything in the cloud? Let's try to run something as near as your data has been, will be. So they go to the edge. Okay, how they do it? Microsoft, it's a software company. So their idea was, we have our components in the cloud, and we move them nicely in containers to the edge. So we need to run it on something. There are containers. There are Docker containers, and they are special kind of Docker containers, because they have a good size. So to get all this setup running, you need at least an IoT hub and a container which ensure the communication between container. The rest is your payload. Okay, they package all this stuff in some hardware and then some software. And this is the DK as we know it now, which is at the end of his will stop working as it is in the 13th of March. Yeah, you see it pretty much up here, and unsupported March 30th, 2023, blah blah blah, and so on and so forth. Okay, getting back, what are the components? These I do not have a second camera, and also this is the place where the container live. This is the camera, but it's not only the camera. They have a special inference processor. So what's the inference? They take a model and they run it on hardware, and they get the results. And this is below this one. It's the microphone. They know also a microphone. Usually what it's in the box, it's something like Alexa. Okay, everything it's Anki-Dory. What we have used this, okay, to create very interesting solution on recognizing insects, for example. Because when you trap an insect, yes, you can take the picture and you learn from the picture, but also you know from the sound. Okay, but this is the hardware part. Let's see, let's go to my portal and let's see what's happening there. because also in the portal there is a component. We'll connect to it, and it's called Azure Percept Studio. Again, this, as it is targeting DK, will stop working at that time. But this does not mean that won't be as successful. And this is why we're very well on this conference. Well, you'll see also why. So let's see what we see here. You will see I took the steps to set up the DK to be connected on the network. They has a, let's say, a setup. You can set up the network. What are the limitations? Normal limitation, you cannot open another page. These are the right ones. So let's go on device. Here we're gonna see component by component. It's the big component. You see it's running Linux. I can say that it's running Mariner Linux, which is pretty industrial. The Linux, everything, it's nice. You have also the vision module and the speech module. Everything is also, you see here, you have also the update service for each module. It's activated, it's work like an edge device, like Microsoft should. It's a good demo of an edge device because everything works on the box. In fact, this hardware was built by Asus, so it's pretty common in doing, know what it's doing. Let's see in a device hub what's happened. So we're working, going to IoT Hub. You'll see that if you have used to other devices, it's a different look. But what you see here, they are the containers. So you see you have the IoT Hub and the agent for doing communication and the rest of the stuff. This is payload. Okay, going from the other side, you have a much better presentation from Dima before. We can go to customvision.ai if you know the site. You know that you can have up to 2 projects free. So you can create here a project. Let's try to create one just to see what are the options. So you have classification, object detection. Let's remember this: classification, object detection. So essentially, for example, another example, we have used this camera to see the diseases in plants. Diseases in plants, we are interested in classification. So we have a leaf picture, and that it's a funny story. Yeah, we look for leaf pictures all over the net. And unfortunately, everything with good documentation, a lot of pictures, were for marijuana. Yeah, there are the geeks that are doing this. And detection, it's also when you have a boundary. You know where it is. Okay, what are the steps you need to do on an image? So essentially, you upload here images to train a model. The model will be trained in the cloud. So let's upload an image of some. In fact, we have uploaded. You need to tag it. So let's see. I have created here 2 models to see if which of my cats, I'm let's say a cat person, is in the picture. So if we try to do this process of tagging, here, what you need to draw a rectangle and say which label. Here we have 2 cats, which is with 2 names. What is smart in cognitive services.ai, and it helps you. You are already pre-proposed these boundaries and the labels. In the other one, if we're getting the other one, again, here will be proposed only the tag because you do not have the boundary. Okay, so essentially, getting from this side, we're getting to the custom vision. You are loading images. You're doing tagging. Tagging, it's a better if there are image label, which is the run-of-the-mill tool. That it's far more painful to do this. Here on cognitive services, they pre-propose you the rectangles, they pre-propose the labels, everything. So you're having, and yeah, you are doing this operation, and then you are starting to train the model. You are doing training. Also, you can do test it. You can throw pictures at it and see what happened. What it's important here to remember, there's the model, it's as good as the pictures and the labels. And also that you should have negative labels. So you have negative pictures. For example, in here I have some also, in one of them I have pictures of me, which I'm for sure not a cat. Not here in the other one. Nevertheless, okay, so we do this, we train the model. And so what? What to do with this model? So getting back to, let's go to the portal in Azure Percept, which we are getting here. We can go to vision, and we see already here listed our project. So we can just click and we deploy it on the Azure Percept, and this will do the recognition. I'll say it's a very fast way of doing it. Okay, getting back again. Remember that on the Percept, I would say here on this, under this big radiator, it's a special chip which, strangely enough, was invented in my hometown, which is doing the inference. Can run with 2 cameras. In fact, I'm not sure if you see it, but nevertheless, because this device is dead, can run with 2 cameras only, because this is how powerful is the chip. Okay, there are some other, let's say, uses for it from Intel. Also, there is a whole story, but this is not our focus. Let's not forget, but one of the partners in this event, it's NVIDIA. But getting back. Okay, and let's deploy a model. We have also models of models, demo models already existing, and we can do it. Let's deploy one to see how heavy it is, because unfortunately here in this room we have people and not cats. So to see what's happening, let's deploy a sample model. Again, we'll take people detection from the live stream. So let's deploy the device. So this is already deployed. We have here for debug, as you've seen there, it's view stream. So if we are in the same network, we can connect to the Percept and get the images and the results. These are not going back to the cloud. In fact, we'll see, in fact, you can see what is going to the cloud and how it looks. There is more than one way of seeing this. This is the simplest one. You have also in the Visual Studio Code. So you start seeing, you're having a bounding box and you say label person and confidence. So the bounding box is the quadrant, the label is person, because yeah, we can have more labels. But they always send a label of something, and the confidence. What you need again to understand in the custom vision and artificial intelligence, we're not talking about certainties. We're talking about percentages. So what is above a threshold, it's that. And the time. This is a strange time. It's not Unix time. It's again from 1970. but it's not Unix time, needs a bit of processing. But we were, let's say, had an advertise that we have telemetry. And you see that the model it's not working, even though it's seeing something on the floor and not my friend Bernie. Say hi, Bernie. It's not recognized as human, as a person. But anyhow, you see that it's a low percentage. It's below. Usually in our models, we're having 80% or 0.80, which is the success threshold. Anyhow, the model is not perfect. Again, it's a sample model. And again, if you want to do a good job, you need to have the good picture and somebody smart doing the labeling. And also it could help to have filters. Getting back. We've seen how the data is trickling up. So we've seen that, let's see again the telemetry, because it's still running. What we not gonna change, because I'll say Dmytro Percept DK, it's now we see we had a couple of not recognized items. What is not going to change, and which is most common in the industry, is this way of sending data, as you see it in the screen. And Microsoft with NVIDIA already announced the new versions. So let's try to see how it would look. So, and Microsoft and NVIDIA partners on will be the new Percept. The new Percept, at least, will be the first announced will be a heavier device. It's a server. It's running with an NVIDIA chip, and it's okay. It's half on length, one something like this, and it's running with Azure Stack HCI. Do not confuse Azure Stack HCI with Azure Stack. This is Azure HCI. It's more closer to Windows Server than to Azure Stack. Nevertheless, okay, why in the earth should we use that? This works with more cameras. We're talking about something like 20 cameras. So for example, you have already cameras deployed around your office building. You can take all these cameras and run something on it. For example, you can check if the people are getting in the places where the badge colors are okay. And everything, it's again, it will be a seamless, easy experience. And also, we have a better, let's say, bigger performance, because here we have a bigger server. We're not having something like in more or less in the Raspberry Pi category. We're having here something very powerful that can run signals for, anyhow, that can run stuff. And we have a powerful chip for NVIDIA can run with 20 cameras instead of 2, which is a huge difference. So we are now opening a lot more applications. So let's try to see again, going up with the data, what we can do with them. Because you see, let's remind ourselves how the stuff it's going. So we're still getting this data, and this is not something that it's humanly usable and has any meaning to anything. So let's try to do something on top of it, and pretty simple. Let's try to count the people which are in this room. Let's try to see again the web stream, what's happening. So we are better, but again, as you see as the issues, the model recognizes from time to time a person and then forgets it and then recognize it again. So for this, you'll need somehow to solve these issues. In fact, not to count a person twice, and anyhow to remember somehow the person around the time. And this is one of the reasons that I'm in this room, because you can see how the stuff is working. So let's try to do this. As we see, the data is going to an IoT hub, which is pretty common. But what to do there? Let's say the first idea to everybody will be to let's go by the data itself. To send it to a service bus, but what and how? Because it's not by default, and we want to do it, let's say, pretty cost efficient. So we're gonna use for this message routing. So we'll create some routes. In fact, what's message routing, and what's the issue with why they arrive? In the Azure world, there is one component which you cannot really reliable estimate the cost. So I have help in presentation. That is Stream Analytics. On Stream Analytics, you pay by the number of messages, and you pay also to enable it. And that's it's sometimes you're using the roles to go pick up groceries. So they added in IoT Hub a very simple query language. In fact, there are some rules. And when the rules are okay, they send the data to an endpoint. Bear in mind, they won't send the data to all the endpoints like Stream Analytics, because on Stream Analytics, if the data fulfills all conditions, it sends what the condition said, and if fulfills another condition, it's also send the other condition. Here on message routing, there is pretty much, if the data is picked by one rule, the other rules won't see it. And also they have an endpoint for all the messages that do not fill any other rule. And there are some other limitations. But let's see my rule. I'm seeing that I'm saying this rule. If we're having a label, and if the label is person, and if the confidence it's more than 52%, and we have only 5 of them, because what's here, we can have in a neural network. Let's look again in how the stuff looks. And again, this will see it. You can have more than one bounding box. So we can have here, for example, you see that in that neural network, the array were more than one elements. And okay, we hit here a limitation of the routing. We can have up to 5. So if you suppose there would be more labels, you can add them, but you need to add them in several groups. Okay, and this is sending to a service bus. We can use a service bus explorer. We can send it to a lot of endpoints, but for the sake of argument, we can use Service Bus Explorer for this, but I wrote a simple application, which we're gonna run it now. And I can also show you, this will be, let's say, the full extent of it, something like 21, up to 21 will fill. So let's see what's happening if this started. It's nothing. And why? Because this rule is not enabled. Again, bear in mind, if the rule is running, you will eat the messages. Again, if you are putting after Stream Analytics or whatever, and if you have a route enable, you won't get the messages because they are sent to original it is. So let's save and see what's happening. And we'll need a bit to wait. What is interesting here, even though that we need a bit to wait everything to spoon up, the messages are not lost. The moment we click start, they are starting to be buffered. And you'll get them there. Let's see what's happened. So we're still waiting for the messages. Let's see if we are having them. We're still having them, and also let's see what's happening here. So as you can see in here, we are in between sessions. So people are gathering here in the speakers room. So you see that you are starting to get the messages also here. Okay, you said I have the messages in the service bus. How it helped me to count the number of persons? Well, simple. You're taking up from, let's say, from inside of Azure, and now you can run code and do stuff on top of it. So you can have on, for example, this application, instead of displaying that, can create a state machine workflow by boxes, and say what's happening in that box if we are person, and try to do a numbering. You are doing all the process. It's a way you get them out. In our case, for example, we have used mostly classification. In classification, we again did the state machine. If we have a disease and we have an insect, we put a flag and send notification if needed. It works. So now let's stop the rule and move forward. So this is and again, if you ask yourself how do you pay these routes, you're paying by number of messages. There are some, let's say something like 2,000. I do not remember them, but you pay by number of messages processed gone to the route. So that's pretty clear. Let's not lose time and open another portal to go to. Okay. And go to Stream Analytics. So essentially, IoT Hub and Stream Analytics go together, love and marriage. Usually, in almost any architecture, you're mentioning IoT Hub, you are going to Stream Analytics. What's Stream Analytics? If you are not familiar with it, it's something akin and alike telephone switchboard. Has a query, looks at the data, depending on the data, can do some processing and send it over. For example, we can send all the data to a database. We can send the data from, let's say, the data shows that there is a disease, send it to a service bus that will go to notification services, or stuff like this. The language at the heart of the Stream Analytics is something like SQL. It's not full SQL, it's a version of it. So this is the query which is in the heart of the Stream Analytics now. We're trying to process that JSON. So now you're seeing here below, you're seeing the data live going, how it looks. So if we're getting raw, you're seeing the bounding boxes and all the decoration. So here we want to get it flat and send it to a database. First we're trying to get the bounding box corners. We're trying to get the label. We are doing the processing for the time. Because I said it's from 1970, but it's not quite Unix time. And also we're putting a level of confidence because we do not want everything to go through. How I said, what in real world, what's below 80% or 0.8, it's not that. But here, you know, for demo purposes, because as you see, this model, it's one thing, but still it's a demo. Yeah, we're putting 0.45. Again, we're not running this because I said this is on the expensive side, and also you pay it forever activated and by number of messages. What is doing always this? It's sending to anyhow flattening the JSON and sending the database, because then afterwards we can play a bit with SQL and try to count the people. Okay, and let's start this and let's look into the SQL and let's discuss. Because this is okay, we'll double check that here we're getting something. I see here the timestamp is very nice, but we are not getting anything because the rule is disabled. And we'll start this. Here again, if you started the spin up takes a bit, but again, you are not losing data. What is very strange, and I hope that did not change it, strange. Percept, it's we have stream analytics. It's one of the few components in Azure which are computer real time. So they are saying the moment that the data it's at the door of stream analytics, it behaves real time. Okay, nevertheless, spinning up, it's pretty slow. So we'll take a bit to spin, and then we'll send that in the database. So let's remind ourselves how the data is looking. It's not the now we, for example, doesn't recognize anything, but our problem is how to count this, because you see the bounding they are moving and not all the time unrecognized. So first we need to see what we have count and what is the same. So there are let's say a couple of ideas of how to do this. The first one, for sure, we need to do a count on an interval of time. Let's say on 1 second won't be that much, let's say, smart. Say more to a minute or a bigger interval. But how do you see that the same square is the same square? So first idea will be, let's calculate where is the center of the square. So we have the bounding box. And if the bounding box center moves in the quadrant of something, it's the same one. And we count the distinct one over 30 seconds or over 1 minute. Second one, which, okay, second idea would be to see the area of the bounding box, because the area for an object won't change that much. Again, will be the limit, let's say potentially 10 or 5% or 10%. And see if the area of the bounding box did not change. Let's count all the distinct boxes over some interval, or try to combine this. First, let's see that we have data here. So let's go to the database. We're having here a database. This is SQL Server. Yes, it could be everything and anything. SQL Server, because I do not know why. With SQL Server, you will know that it's spun down sometimes. But if you want to do it cheaper, sometimes database will be stopped until it does not have data. In this case, everything it's working because I worked with it before. And also, yeah, it will work to a Postgre. I'll say I'm a huge fan of Postgre. I've been from the very beginning. And let's see, query editor. This is in preview. Let's try to see, okay. Let's connect. Okay, whatever. We have the tables. The tables I created. So I practically flattened the JSON file. So I have a bounding box, I have a label, a confidence, and a timestamp. This is, you can do it however you want it. And I created a number of views. But first, let's see this one. Select top 1000, but we'll stop it because there are a lot of data. Let's say top 100, order by timestamp desk. And let's see what we have here. Again, I'd say this was done for price, not price optimized, because it's my demo tenant and everything. And this database really grow. Yeah, again, you should bear in mind that this kind of custom vision solution are pretty chatty. They're sending a lot of data. On the other hand, as you have seen, the data is absolutely GDPR compliant. You do not send, you cannot identify me by a bounding box or by label of person. In fact, my wife said that I do not qualify as a person, but that's another story. You see that pretty much this is what's inside. And we have also the timestamp in this strange look. Let's try to do some okay, this is better to see the stream analytics query. As you see, it's more than 0.45, and you see it here that it's more than 0.45, so we have confidence. Here I've tried somehow to aggregate this per minutes and per seconds and try to do some calculations. So let's see what we have. We have, let's try the view per second to see. Okay, the first one will show us the time nicely. Let's. If I'm right, yes, I'm right. By this is time stamp desk. Because yeah, it's not called this. It's ingestion that time. Okay. When in doubt, I always can go here because so you see also this. Now we are in the good day, 6th of December, but the time is UTC. I'm usually saying GMT, but people are jumping me because GMT and UTC is not the same thing. Okay, it's not. Bear in mind the Azure, it's usually going by UTC. So let's try to see this one again. Order by. Let's copy this. And let's run it. Okay. Most probably it was the second row, but not. So it's in fact, let me see how the time second ordered by time second.
Thank you, welcome. Okay, keep yourself.
Run. It happened that it looks almost okay. It's not, but okay. As this demo work better than I expected. So let's get them order by a time, minute, desk, and okay, you have here abnormalities, but generally, yeah. So you see, this is not perfect, but it's perfectible. Both as the model side, both as the queries, but you have a good start. Sometimes you don't need to be that precise. Okay, these kind of numbers are not acceptable, but yeah. And getting back to the slides, this is, you still find this big picture will remain. Also, I say, the inference chip is moving for sure to NVIDIA, at least on the big one. There'll be a new version of Percept. We're waiting for it. There are a lot of applications. So pretty much it's everything. I'm hoping I'm still on time. Thank you very much. If there are questions.